And I do want to thank everyone for joining. If you have questions, if you can, you're welcome to come off of mute. If you're having a problem coming off of mute, a few people were earlier, let me know. And you can maybe raise your hand or just pop a question into the chat, and hopefully I'll see it. At the very end, if I didn't get to any questions, I'll just take a minute and go through the questions that I can find. So a little bit of housekeeping before we drop into tonight's topic. We've got actually we've got a lot of non-direct Cisco related topics, but they're all kind of networking related. So next month, I think I mentioned before, we're going to do go over security operations, like building a security operations center as a service. It's a company called Xenix we've partnered with before. They do a SOC as a service sort of thing, but he'll also talk about what it takes to build your own security operations center, what some of the benefits of a security operations center are, especially if you have to do things like cyber insurance and so forth. That'll be in April. In May, we're going to take a look at machine learning based security algorithms. So how can you do things like, we all hear about those kind of holy grails of, being able to take all this data from all these different places and correlate all these different things. We're going to take a look at a company that actually specializes in that. If anyone remembers Dana Yonch, he presented on Cisco SD-WAN several years ago, maybe like it was like right before the pandemic. It would have been probably late 2019. Really bright guy. He now works at another company. He's going to present on that. And then in June, we're going to cover Thousand Eyes. So that'll include a demo of their product. If you're not familiar with Thousand Eyes, as an engineer, what I think I like most is some of their blog entries where they go through and they take a look at outages, and then they give you the analysis of why there was an outage, right? So there was a really good one, maybe about a year ago, maybe less than a year ago, for Facebook, where they were able to monitor that there had been an operational change made at Facebook where they accidentally withdrew a bunch of their routes from BGP, and then you see the routes come back into BGP, but they notice that there's a route missing, and apparently Facebook didn't realize that there was a route missing. So there was this extended outage where some people it was working and some people it wasn't. It was kind of fascinating the way that they used their tool to kind of digest all those things. So June will go through Thousand Eyes. If you ever have any suggestions for topics, I'm more than open to it. I'll put my email in the chat. You can always just email me and I'd be happy to see if I can line up a speaker, or if it's something that I feel comfortable talking about on my own, like I'm going to do tonight. Of course, I've presented at this group hundreds of times, so I don't have a problem presenting on it myself if it's something I have at least something slightly interesting to talk about. And speaking of that, we're going to get into tonight's topic, which is kind of AWS networking. And this is a little bit different if you've seen my AWS talks in the past. We're not just going through, we're not going through a more general AWS overview. We're going to really drill and focus mostly just on the core networking concepts tonight. We'll start with what I kind of consider some of the fundamentals of networking in AWS, and then we'll move into some more kind of secondary concepts. And then we'll take a look at a few use cases where we might tie some of these concepts together. And I'll try where I've thought about it, put together some recommendations or best practices. And like I said, if you have questions, you can just come off of mute and ask them. Some people were having a problem coming off of mute. If you can't seem to come off of mute, pop a question into the chat and I will try to get to it. And if anyone sees them in the chat, please feel free to come off of mute and just let me know if I miss them. Okay. So you can see it's a pretty packed agenda tonight. We'll talk about, there's only two general AWS slides. That's the building blocks and the global infrastructure. And then everything else is really straight into network concepts and designs. One thing though, you see a whole bunch of drawings tonight. And they're all accurate. I'm not hiding anything or lying about anything in here, but we're really kind of scratching the surface, just like any topic we do, right? Um, and just because I throw up a slide and I make some recommendations, that doesn't necessarily mean that it doesn't really necessarily mean that you can just take that slide and build the same thing and launch it into production. You probably cannot. I mean, some of the basic, simpler things, yeah, you could just create your VPC and attach a CIDR block, but you want to do something interesting with that VPC and that CIDR block. And so when you get into the like putting it all together slides, there's a lot going on there. It's hard to put it into just one drawing. So at the end, though, if you are interested in learning more, we'll talk a little bit more about this, but the next bullet item also covers it, which is you can just make a free tier account, right? You can create your own account. I do an account pretty much every year. It just takes an email address, a unique email address, and a credit card. The credit card does not get charged unless you bust out of the free tier. I think at the end, I have a link to what's included in the free tier so that you can kind of be careful about that. There's a lot in AWS that is included in the free tier. And if you're wondering why would we even talk about AWS at a Cisco user group, there is a link. If you'd like a copy of the slides, you can email me. My email's in the chat, and I'll be happy to send you the slides. But Cisco has quite a few AWS offerings these days. Also, I guess I would argue that everyone is impacted by the cloud these days, right? Infrastructure as a service cloud, which would include AWS and Azure. It's kind of everywhere. It's fairly ubiquitous at this point. There are still um, some places that don't do it. It may not make sense for certain smaller businesses or very highly regulated businesses. They might struggle with it. But if you've got a development shop, cloud is really kind of a pretty exciting place to be because everything is built on these APIs and everything like that. So it's a pretty fascinating place to work. A lot of people have to work here. So let's see if we can do it with some best practices in mind, right? Okay. So these are what I call the AWS building blocks, right? You have your global infrastructure. That's basically all the stuff that AWS owns, right? That's things like the fiber and the data centers and um, the power feeds and things like that. And then there's all the things that interface between the global infrastructure and your customer account. And at the base of all that is networking, right? And you can see everything above networking rides under networking, and networking rides on the global infrastructure, right? So we're not going to cover things like the compute, storage, security, etc. But just be aware, networking is really kind of the fundamental foundational part that you kind of set up before you can do things like building out your compute, building out your storage, building out your application services, etc. Security, of course, although I have it as its own brick, security goes across all of these, right? You secure your compute infrastructure, you secure your storage infrastructure, you secure your network infrastructure. All of this gets wrapped in security, of course. So when we talk about global infrastructure, here's the most up-to-date map I could find from AWS of where they're located in the globe. And it's probably not accurate anymore, even though I just got it about a month ago. They're constantly changing. So they are across more than 30 regions at this point. A region is a geographic location, basically, where they have a presence, right? So the region I probably work in the most is the Oregon region, which is on the West Coast. There's also a Northern California region. It's a little bit limited. And so most of my customers are up in the Oregon region. The other region I work in quite a lot is US East, which was the first ever region. That's over in Northern Virginia. And then I do, oddly enough, I do a lot of work over in the Central European region, which is in Frankfurt, Germany. Although I've worked in many other regions, I'd say those are the three that I tend to seem to work the most in. And then there's a concept of availability zones. So a region isn't just a data center, it's a group of data centers. Typically, not always, but typically it's a minimum of 3 data centers that are geographically far enough apart that they can take things like separate telecommunications feeds, separate power, separate cooling, close enough together that they can all communicate with quite low latency, like, 1, 2 milliseconds is pretty common. So within a region, you have multiple availability zones, right? So you can have regions at the top, and availability zones belong to regions. And then there's a newer concept, just came out, I think about a year or maybe year and a half ago, something like that, called local zones. These are basically an extension of a region that's kind of localized to a specific area. So for example, Los Angeles has a local zone, which is extended down from Oregon. And a local zone is not a full availability zone. It's not a full region. It just extends some of the regional capabilities down to a remote geography. So you can basically extend some of the, let's say, Oregon regional goodness down into the Los Angeles local zone. And then you could do things like write your data up there and then ride the AWS backbone to get it back up into Oregon, for example. This could be nice if you have like a large footprint in a local zone and you want to provide some kind of more localized connection to some of that footprint. A quick recommendation is we're going to go through a lot of services today. You really want to learn, if you can, if you're going to spend much time in AWS, take the time to learn the differences between which of these services run at the account level, at the region level, the availability zone level, the subnet level. This really helps you understand the impact and the limitation of each of these services. I'll call it out on a few of these slides where they kind of run, right? We'll start with the VPC. So the most kind of fundamental unit of networking in AWS is the VPC, stands for Virtual Private Cloud. And the VPC, it's a regional construct, right? This runs at the region level. That means the VPC spans all availability zones within a region because it's in the region. It's automatically in all the availability zones that are available to that region, right? So yeah, it's a regional construct, and it's automatically spread across all the availability zones, right? I mentioned that. There is something called a default VPC. It can be a little bit helpful when you're first learning AWS, or if you just want to sandbox something. I rarely see it used in production because it's not very extensible for production. It comes pre-built with a CIDR block, 172.31.00/16, and IGW. It's all pre-subnetted. Everything's kind of pre-built for you. And it's the same in every single region. So you have this default VPC and it's in every single region, all overlapping IPs, so you can't really interconnect them or anything. So again, it's helpful maybe if you're just trying to do something in a learning perspective, or you just want to spin something up real fast and try it. But most places I find do not use the default VPC. And in fact, my recommendation and AWS's recommendation, just delete the default VPC. It only leads to confusion eventually. It's used to not be recommended by AWS, but they made some changes on their internal infrastructure that now you can indeed delete that default VPC, and they actually recommend that. So I would recommend it as well. Really, to create a VPC, the only thing you need is a CIDR block. It'd be kind of boring if we don't put anything in it, but technically you could create a VPC and all you need to create it is a CIDR block. IPv4 is mandatory. IPv6 is supported. There are some caveats. The CIDR block could range anywhere from a /16 to a /28. You can do more than a single CIDR block. You can do secondary blocks as well. You can have one primary, and I think by default you can have 3 secondary CIDR blocks. I believe that's a soft default. You can technically go up to, I want to say 16 CIDR blocks total. You have to request an extension for that. All of those CIDR blocks could be edited except for that primary CIDR block. That can never be changed or edited. So when you're planning out your network, the very first thing you need to do is start thinking about not just my CIDR blocks, but what's my IP addressing scheme look like in general. Very similar to if we were building a data center, right? We don't start with the VLANs, we start with our overall CIDR block for the data center in its entirety. And we give plenty of room to grow. So if I say, well, I'm going to deploy up in AWS, I don't know how many regions I'm in, maybe I'm going to set aside 10.1.0.0/16. And I say, well, I'm going to be in 2 regions. I might not want to take that /16 and just break it into 2 17s. I might want to give myself a little wiggle room in case there's a 3rd or a 4th or something region later on, right? So you want to plan all those things out the same way you would plan out any data center or network that you build, right? And within a VPC, once you create a VPC with its CIDR block, it automatically gets something called an intrinsic router. You have limited influence over the intrinsic router. You can basically program it with static routes, and there's a few other things you can do, but there's not a lot. The intrinsic router comes with a lot of caveats. It can handle a maximum of 100 routes. The default's actually 50 routes, but you can ask for an extension up to 100 routes. If you've ever dealt with routing, at any scale at all, you know that 100 routes is hardly any routes at all. So you need to really think very closely about how you're going to handle your IP addressing, right? So that you can do things like summarization. So I'm not, blowing past that 100 route limit. I can tell you from personal experience, if you go over 100 routes on these intrinsic routers, it will be a hard outage. It's not a fun time. It causes something called a BGP freeze. So yeah, it's not good stuff. Yeah, you want to avoid that at all costs. The next item, the next item is WebEx is being a little annoying, sorry. Our subnet. So I've created my VPC with my CIDR block. Now I want to carve up that CIDR block into subnets. In my example, I've got my VPC spread across just 2 availability zones, AZ1 and AZ2. And the subnet is an availability zone level construct, right? So the VPC is a regional construct. The availability zone is a subnet level construct. That means anything that you put in the subnet object can only exist in a single AZ. right? It can talk to other AZs. It does so through that intrinsic router. As you can see, all subnets are automatically connected to and default gateway to the intrinsic router. You can override that in some cases, but that's the default behavior, right? It's pretty simple to build out subnets as well. You really just need to know what VPC you're working with, and you don't have to name them. It's usually pretty helpful to name them. In fact, I'd say it's helpful to name all of your AWS objects. So you should get used to or be in the habit of coming up with a naming standard for AWS as well, so that you can kind of name your objects to make it easier for people to, if they're in the console, it's easier for them to navigate around. And then even if they're not in the console, they may be able to utilize standardized names in scripts or lambdas or things like that, so you can deal with objects programmatically as well, even if you're not going to use the console. You could have many subnets in a VPC, and in fact, that's not an uncommon thing, is to do subnets in tiers. So using this example, maybe I say I want a front-end tier, I want an application tier, and I want a database tier or something like that. And I want that across two AZs. That would be 6 total subnets, right? 2 for front end, 1 in AZ1, 1 in AZ2, 2 for application, 1 in AZ1, 1 in AZ2, and 2 in database, 1 in AZ1, 1 in AZ2, 6 total subnet objects, right? So it's not uncommon to do that. You just need to be aware that all the subnets need to come out of the CIDR block that is attached to the VPC. This is why we sometimes add secondary CIDR blocks, right? Is if we hit unexpected growth, the way around it is to add a secondary CIDR block into the VPC, and then I can carve up more IP spaces. Obviously, we prefer to just plan it out appropriately, but you can only do what you can do, right? Just remember that that intrinsic router is auto-attached to in the default gateway for every subnet in the VPC by default. And your subnet can size the same as the CIDR block. It would probably be not a great practice, though, to take the entire CIDR block and put it into a single AZ. You would never be able to then add more subnets. That's how we had a question come in. Give me just a second here. Why we need a secondary subnet in the zone? Yeah, it's a good question. So there might be a couple of reasons, but one of them is this best practice at the very bottom, right? A lot of times we want to deploy our applications across multiple availability zones so that they're more highly available, right? I believe, don't quote me on this, but I believe that the SLA for a single AZ is 99% or 99.9%. But then when you split between two AZs, that goes up a couple more nines. So you get a lot more resiliency when we split across multiple AZs. I find from a subnetting, this probably is not surprising to anyone with a networking background. I recommend that you always have a power of 2 for your number of subnets. So I always tell everyone you can have 2 subnets or you can have 4 subnets, right? There are no regions that have 8 availability zones. I don't know why you would deploy into 8 availability zones anyway. For most of my customers, 2 availability zones is fine. And what they'll do is they'll put their resources in both of them and split them up so that if there's some kind of an outage or some kind of a brownout in one of the availability zones, all their resources in the other one are still good. We're not going to get into application design here, but this gets a lot more powerful with things like load balancers. We will talk about load balancers tonight, but obviously we're not going to get into the application side of things. But you could put something like a network load balancer in here or an application load balancer in here and deal with that. So The main reason is exactly what I have down in our recommended best practice, which is high availability. Can't say that one quickly. I will warn you up front, you do pay extra money to push data in and out of an availability zone to another availability zone, right? So I don't pay for data in, data out if everything stays in a single AZ. So that's the more cost-effective way of doing this. I do, however, pay to go between AZs. So I don't know what those charges are, so please don't ask. I'm just not sure. Okay. My slides are being a little goofy tonight. Okay, next up, oh, IGW. So we've got our VPC with our CIDR block. We have our subnets with their subnet IPs. We have our intrinsic router. We probably want to be able to get in and out of our VPC. There's a few ways to do that. We're going to talk about several different ways to get in and out of our VPC tonight. The first one we're going to deal with is an IGW, which just stands for Internet Gateway, right? Now, the Internet Gateway is a VPC level construct. So it's contained within the VPC. So the VPC is a regional construct. The IGW is kind of a VPC level construct. So it does automatically span all the AZs, but it's contained within a VPC object itself. You create the VPC first, and then you create the IGW, and then you attach the IGW to the VPC. So you'll need to know the ID of your VPC. This is pretty self-obvious if you've deleted the default VPC and you just have a single VPC. There's only one to pick. If you have a bunch of VPCs, you're going to need to be able to track those objects, right? So again, think about things like naming standards. The VPC ID is actually unique from the name, but the name will be next to the ID. So that makes it easier to sort and look through things. And you know, it's honestly, it's really what it really is. It's a NAT device that basically connects into their public backbone. When we configure NATs in AWS, I'm not covering NATs tonight, but there's something called an elastic IP, which allows you to do a one-to-one NAT. That elastic IP, it looks like it's on the NIC of your server, right? It looks like what we call an ENI. It looks like it's on the ENI of the server. It's actually not. That's just how they represent it to you. It's actually over on the IGW, right? And so your EC2, your VNIC just kind of sends stuff over to the IGW. The IGW just says, do I have a one-to-one NAT? Do I have a one-to-one NAT for that ENI? And if I do, I'm going to go ahead and let it out onto the public backbone, right? The IGW is automatically redundant across all the availability zones, right? Obviously, I say all the AZs in the region, probably a little more accurately. It's really all the AZs in the VPC because the IGW is a VPC level construct. If the VPC spans all the AZs in the region, then your IGW spans all the AZs in the region. If your VPC spans a subset of the AZs in a region, then your IGW does as well. It's auto-scaling in bandwidth, although you can have a maximum single session of 5 gigabits, right? So you can't have a single session that exceeds 5 gigabits in bandwidth, but you can have multiple 5 gigabit per second sessions. What is going on with my slides tonight? Sorry about that. Any other questions? Did anyone else have any questions? Let me come in and take a look at the chats. I think I got everything from the chat. No? Okay, we'll keep going. Route tables. So if you're a router nerd like me, and I am a router nerd, you spend a lot of time dealing with the route tables in AWS. I have an example at the very end called putting it all together, where we'll go through what these route tables might look like when we start to scale up to something a little more interesting than just these simple things. But everything I'm showing you right now, you can do in the free tier and not get charged for. You could build all this out, right? Now, like I said, you can't just go and take my thing and maybe deploy it exactly as is, but you could go up, create a free tier account, and start playing around with this later tonight, and it won't cost you a dime, okay? So, and it's a great way to learn. By the way, that's true for AWS. It's also true for Azure. Obviously, they don't call them VPCs over there, and they might have some different terms, but Azure has a free tier as well. You can create your VNets, which are kind of similar to your VPCs, and your subnets, which are just subnets. Uh, so you can do the same thing in Azure. I haven't used Google Cloud in a while, but I believe that they have a free tier as well. So everything I'm talking about is kind of AWS centric. Almost all these concepts we've gone through and all the concepts we're going to go through in the basics section will apply to any other cloud you're working in. Yeah, okay. Chad was able to verify. Yeah, Google still has a free tier as well. I knew that they used to. I just haven't used Google in quite some time, so I wasn't sure if they still did. It makes sense. I couldn't imagine them not having it. So it's good to know. So let's talk about the route tables. This is a VPC level construct, right? Although you can confine a route table to a single subnet or availability zone if you want to, right? So the route table's a little more malleable than the other objects we've talked about so far. You could take and put a single route table into a VPC and have it route for all the subnets that are in that VPC. That's what we've done here in this example, right? I've got a local route that is tied to the CIDR block. That local route, by the way, that's not really a static route. That's just part of the intrinsic router. You cannot alter it in any way. You can't remove it. You can't change it. Nothing, right? And then I've added in a static route that just says, hey, your default goes to the IGW. And that route table will route for all of the subnets in this case, right? I could also, though, take that route table and tie it to a single subnet, which means now I've limited it down to a single availability zone. And so you could do route tables per subnet. You might ask, why would I do a route table per subnet? It gets you a lot of granularity in how traffic might route. If I had, remember we talked about tiered subnets before. Think if you had a pair of firewalls, right? And you had a public set of interfaces, private set of interfaces, and then maybe a heartbeat set of interfaces that just do synchronization and heartbeat functions, right? You might want different route tables for public, private, and heartbeat. Heartbeat maybe should only route to the local devices in that subnet, right? Whereas your public needs to have a default route that points to the IGW, and your private might have a route that says, hey, to get to 10.0.0/8, head back to the TGW or to my BGW or something like that. We'll talk about what TGWs and BGWs are coming up. So a lot of malleable capabilities within the route table. As I mentioned before, there is a 100 route limit on the VPC routing table, right? And that is a hard limit. Your soft limit is 50. You can request for it to go up. You have the ability to explicitly associate a subnet with a route table, and I strongly recommend that you do. I don't like not explicitly associating subnets with route tables. That will work if you have something called a main routing table. Basically any subnet that's not explicitly associated with a route table is implicitly associated with the main routing table. I don't care for that behavior. And in fact, I typically recommend just delete the main routing table and always explicitly associate subnets. There might be some other reasons not to do that, but I'm a fan of it myself. So In most cases, I would say that's a good idea. So one thing that's a little unique in the route tables in AWS is, if you're used to Cisco routing, of course, your next hop is always an IP address, right? But in AWS, your next hop might be an object, right? The IGW doesn't have an IP address. I just say your next hop is IGW object, right? And there'll be an object ID. So that's kind of how we configure route tables. Any questions? Okay, keep moving on. We'll talk a little bit about VPC security. This could obviously be its own topic. Like I said, security spans everything that we do. Honestly, not just in cloud, security just spans everything we do, period, right? Or it should. If it doesn't, we pay the price. There are three main types of security that we think about when we talk about VPCs. Those are flow logs, network access control lists or NACLs, and security groups. Flow logs are literally the flows that are handled through the VPC, through the intrinsic router. You need to be able to send those somewhere, like so that they can be stored and audited later on. So if you're going to use flow logs, you need to send them somewhere. That means you're going to have to pay for storage for them, right? NACLs are attached at the subnet level. They are not stateful. So, NACLs you need to program bidirectionally if you want bidirectional communication. And they're not terribly granular because they attach at the subnet level, right? That means everything within a subnet can intercommunicate freely and the NACL doesn't see it. The only time the NACL sees traffic is if it's coming into the subnet or leaving the subnet. It doesn't monitor anything that's happening in a subnet. And then lastly are security groups. Security groups are attached to what we call an ENI. It's the same thing as a VNIC, and they're stateful, right? So I don't need to worry about bidirectional entries. In fact, the default outbound security group rule is permit any. That's because we typically put a lot of rules into the inbound side of the security groups, and that default permit any doesn't even take effect because, in fact, if you look at it, it has a very high number. I think it's at 100 or something like that. So it usually never even gets processed because usually the traffic comes in and the reverse traffic just goes out in a stateful manner. Same thing you would see on a firewall, right? It's worth noting you cannot launch something in AWS such as a EC2 without associating a security group to it, right? So take the time to actually build a security group and don't just make it any, right? This is probably one of the biggest problems I see with security in all clouds, not just AWS, is people will launch and they're like, oh, you know what? I'll figure out what ports and protocols and IPs and things I need later on. I'll just make it IP any for right now. And later on just never comes around, right? And then something's gone production, and then you say, oh, you know what? I need to lock that down. And they're going to be like, well, it's working. I'm not going to let you make changes, right? So my recommendation for a best practice here is I don't often see NACLs being used. I wouldn't say it's a best practice as much as what I most commonly see. Because NACLs are not stateful and because they only are attached at the subnet level, I just don't see them used that often unless there's a really good specific use case. They also don't perform or scale as well as security groups. So for the most part, I see flow logs if people can afford to store the the data from their flow logs. And you have to see security groups. Again, you can't launch an instance in EC2 unless there is a security group that you attach to it. You just can't do it. It won't let you. So I find security groups are the more natural security mechanism. Any questions on that? Sometimes security groups and NACLs are a little confusing for folks. Yeah, I see. I prefer security groups to NACLs myself. I use NACLs though if there's a specific reason to use the NACL. So, for example, if you say something like, you know what, I never want internet traffic to come into any of my AWS resources. It's just a private environment. I don't need any internet in there. And all of my entire organization is addressed out of 10/8. I might create a NACL and I would almost do this. I would do this programmatically. I wouldn't do it statically, unless it was a very small environment. I would just say like, hey, every time you spin up a new subnet, you attach a NACL that says permit 10.0.0.0/8 and do that in both directions. And I'll still maybe filter down more specific rules on security groups. But then I've got a NACL that basically it's just a nice layer of protection that says I will never allow anything with the private 1918 10/8 range in. But honestly, you can do that exact same thing in security groups as well. So I'm more of a fan of just do the security groups. They're more extensible, they're stateful, they're more flexible, more granular. If your company is kind of big on NACLs or they just have a policy where they like it, go for it. I don't have a problem with NACLs per se. If you're looking at a really complex NACL deployment, I would strongly, strongly recommend you open up a ticket with AWS, or if you don't have enterprise support, talk to your AWS SE. There are some caveats when it comes to scalability and performance with NACLs. Actually, I ran into this at a company that Chad and I used to work at together. We were looking at a big NACL strategy, and AWS kind of came back and said, hold your horses. These aren't going to perform well, actually. There are some scalability limitations with NACLs. It was a little eye-opening for me. And so they said you could do that in security groups, it'll work great, but in NACLs, you're probably going to get performance issues. So in general, Chad, I prefer just security groups, but I don't really have a lot of heartburn if someone wants to use both security groups and NACLs. I would never use you can't use just NACLs because security groups are always mandatory. Hopefully that answers your question. Oh, are NACLs and AWS similar to Cisco ACLs? I would say that security groups are a little more, well, I guess NACLs are indeed similar to Cisco ACLs in terms of who and how we write them. But I would say that the security groups are more similar to firewall rules, right? Firewall rules are always stateful, meaning that if I allow it in one direction, the return traffic is always allowed, right? So I prefer the security groups because of that. NACLs do have a similar syntax to ACL and iOS. The security group has a similar syntax and behavior to what you would see on a firewall, which again, I prefer. Good questions. Good questions. Net gateways. Let's talk about net gateways. So we deployed an IGW, right? But I mentioned before, you can't really go out the IGW unless you have some kind of a NAT, because really the IGW is just a big NAT device. And a common way, we're not going to cover NAT in depth today, but one of the more common ways to do NAT is something called a NAT gateway. And so you can see now we're getting a little bit beyond just basic. I still labeled this one as basic, but you can kind of see a little bit of what we're doing here. Now I've got different subnets per, or sorry, different routing tables per subnet, right? I have a private subnet and I have a public subnet. In my public subnet, I have a NAT gateway, right? My NAT gateway basically does a one-to-many NAT, right? If I do those elastic IPs that I mentioned before, those are one-to-one NATs. The NAT gateway is doing a one-to-many NAT, okay? And so it's great for outbound internet access. And in fact, it can only do outbound internet access. The NAT gateway does not allow internet traffic in unless it's return traffic from something that was initiated from within the VPC, right? So it's a one-way sort of thing. No one out on the internet can go past a NAT gateway on initiation. However, if I have something in, for example, my private or my public that goes out through the NAT gateway, it tracks that session state. It lets it out through the IGW. The return traffic will be allowed. So this is a good example of why would I want to have one route table per one subnet? Well, look at this. I have all my private hosts over here in my private subnet, and their default route points to the NAT gateway because I want them all to be able to go out to the internet and patch, for example, or do something really important like go to Google, right? And to get out to the internet, they're going to need a NAT. So their default route points to an object, and that object happens to be the NAT gateway. However, in the public subnet, I can't point the NAT gateway back to the NAT gateway. I would just be in a routing loop. So I need a different, unique default route, and that needs to point to the IGW. So the flow of traffic is, when I want to go to the internet, I have my private instance. It default routes to the NAT gateway. It gets to the NAT gateway. The NAT gateway says, well, how do I get to, cisco.com? I go out the IGW. And since I have a NAT configured on this IGW for the NAT gateway, it's NATed and allowed out. So one thing to be very cognizant of is that the NAT gateway is an availability zone level construct. It does auto scale bandwidth up to 45 gigabits per second. However, if you want redundancy, you may need to deploy NAT gateways across multiple AZs. Okay, you can't put if there's an outage or an interruption in AZ2 where your NAT gateway is, I don't have a backup over here, right? Because the NAT gateway is actually tied to the AZ. It's an AZ level construct. I wish it wasn't, but it is. In fact, I believe all of AWS's NATs are AZ specific. I can't think of an example where they're not, where they have a NAT mechanism that isn't AZ specific. So if you want resiliency, you may need multiple NAT gateways in multiple AZs. That does get more expensive though. So you kind of have to weigh these options, right? I believe, again, don't quote me, but I believe that an AZ will have 99.9% uptime. Maybe that's sufficient for you. Maybe you're kind of like, yeah, I can handle that much downtime. I can't remember how much downtime a year 99.9% is. Let's say it's an hour of downtime a year. Maybe you're kind of like, I can live with that. If I lost the internet for an hour, it would be okay. Or if I lost it 4 times for 15 minutes per time or something like that, I can live with that. I will say I don't see a lot of AZ-wide outages. I do see AZ brownouts in some regions a little more frequently. So by brownouts, I don't mean like an ISP brownout, but I mean like, oh, we're having a problem with the Lambda service in AZ2. Oh, we're having a problem with, uh, snapshotting in AZ1. Oh, we're having a problem provisioning a certain instance type in AZN, right? I see those sorts of outages a little more commonly than I see AZ1 is just completely offline. Any questions? Okay. Okay, we talked about the IGW. Let's talk about a VGW. This stands for Private Virtual Gateway, which you would think it would be called a PVG, but it's called a VGW. And like the internet gateway, the private virtual gateway is a gateway device, but as opposed to being public, this one's private. That means I can terminate things like IPsec tunnels on it. In fact, that's what it's mostly used for, is like terminating a IPsec tunnel or something like that on there, right? You can also tie things. We're going to talk about direct connects in a slide or two. You can tie a direct connect into a VGW as well. One thing that's kind of nice is you can run BGP on this, but you need to be careful. Remember that there is a 100 route limit. So if you've got, 1,200 routes in your BGP table, you cannot send those up to your VGW. You're going to crash your VPC. You could send like a summary route up or something like that, or a default route up, but you can't send all 1,200 of those up. The encrypted throughput on a VGW is 1.25 gigabits per second. One thing that's kind of neat is when you deploy the VGW, it has a bunch of pre-built VPN configurations for quite a few different vendor firewalls. I don't know, I'll say 30 plus probably. They're not 100%, but they're actually really good. When you think about how many vendor firewalls and code levels that they have up there, and then you look at the tweaks and changes you need to make, it's pretty impressive to me. But I will warn you, you're probably going to need to make some tweaks and changes. There'll probably be a few things that's kind of like, oh, this is for code level 9.2, and I'm running, 9.12 or something like that. And so some of these commands have changed a little bit. Be aware that the virtual gateway, the private virtual gateway, whatever you're terminating that VPN on, it considers that a customer gateway. So when you're looking at documents, or if you open up a support case with AWS, you're going to hear them talk a lot about customer gateways. Customer gateways are your routing object that terminates, in this case, in this slide, your VPN. You could also have a customer gateway that terminates a routing connection, right? Like BGP or something like that, right? But basically, a customer gateway is any routing object not controlled by AWS. Hopefully that makes sense. Any questions on the VGWs? Okay. VPC peering. I'm going to cover this because I still run across it a lot. I'm not a huge fan of it, but I can appreciate why it's still used, because it works, it's understood, and it's inexpensive, right? So I get why it gets used, but it's not terribly scalable. If I have two VPCs and I want those VPCs to communicate between themselves, right? One of the easiest ways is with something called the VPC peering connection, right? It allows you to route between those two VPCs over the AWS backbone, and it's done privately. It's really critical that you understand this does not support transitive routing. Here I've only got two VPCs, VPC-A and VPC-B, we could call them. But imagine now that there's a third VPC, VPC-C to the right of this peer link. I could peer from A to B. I could peer from B to C. I cannot go from A to C through B. I have to create a separate peer to go from A to C, right? So this is one way in which they're not terribly scalable. If you want all your VPCs to be able to intercommunicate this way, then you need to basically build a full mesh of VPC peer links, but you can't have, well, that doesn't scale well. I think you can only get about 10 or so VPCs to scale up that way. If you go beyond that limit, then you just can't peer anymore. There are some kind of cool things you can do with VPC peering, though. VPC peering can be done between different accounts, and it can also be done across different regions, okay? So it was the very first way we had to be able to get VPCs to intercommunicate. And it does still work. It's just not terribly scalable, right? So if your environment is pretty simple, or if you only need the VPCs to peer temporarily, VPC peering is definitely the way to go. It's very easy to set up. Takes you a couple of minutes to configure it in the console. Why might you only have them peer for a short amount of time? Let's say that my initial deployment of my app was in this VPC here, and I have a new version of that app that I'm testing down here in this brand new VPC. I might want to synchronize a whole bunch of data out of this app down into here to test with. And maybe the easiest way to do that is through a VPC peer, and then I could tear it down, right? I just want to load a bunch of data one time from one place to the other. Or maybe I have two different VPCs from two different accounts. Some large enterprises may vend a lot of accounts, meaning they may have like one account per project or one account per team. Per project's not uncommon, to be honest, right? They may say like, oh, even sales and marketing, they're going to have 50 accounts because they might do an account per marketing campaign that they're launching or something like that, right? And if I need to be able to move data between two accounts or two VPCs, the peer link might be a good way to go. I saw a question pop up, but I didn't read it in time. If it uses BGP under the hood, it's nothing we see. So you got to remember that any infrastructure as a service cloud like AWS or Azure or GCP, we're working in the overlay. We don't get much visibility, if any visibility, into the underlay. In the underlay, it may be running something like BGP, but we don't see it at all. All we see is we create the peering link, and then we go into our route table and we point a route in our route table to the peering object that we created, right? Now, if this is all done in my own accounts, it's very easy to set up. If I do this across accounts, I need to create the peering link, and someone's got to be the principal, and you share it over with the other account. The other account has to accept it. You can't just automatically set up peering to, say, a different account without them approving that. That'd be a big security violation, right? Good question. That was a good question. Any other questions? Okay. Here we go. Direct connects. So now we're getting into what I consider more secondary concepts, right? So these are things I don't see quite as often. And the first one's direct connects. This couldn't be simpler. It's just a private circuit between yourself and AWS, okay? If you're a large enough company that you need private circuits to communicate from your, say, your data center up to AWS, you do so through something called a direct connect. The direct connects do support either static or BGP routing. I most commonly use BGP, but then again, as I've mentioned before, I am a routing nerd. I use dynamic routing at all times if I can. And then after you've kind of ordered your Direct Connect and it's deployed, you build out these things called virtual interfaces. There's 3 types of virtual interfaces, private, public, and transit. You could probably guess what they're used for, right? The private connects to something like a VGW, right? Meaning it's private traffic. The public connects to the AWS public backbone, where all those IGWs are connected to. And the transit connects to something called the transit gateway via something called the direct connect gateway. We're going to get into those in just a minute. So the direct connect it's simple enough. It's just a private circuit. It's just dark fiber you get between you and AWS, right? If you're in a colo like Equinix is pretty famous for having phenomenal connectivity to AWS. They're not the only ones, but I'd say that they have the best connectivity in my experience. I'm not saying that they do, period. In my experience, their connectivity options for these direct connects is it's pretty tight, and their workflow is down to a T pretty much. It's pretty good. So pretty simple. You won't run into it as much. However, if you're at an enterprise that's going to be sending a lot of data in and out, direct connects are a good option because they perform far superior to something like a VGW. Direct connect gateways. So we talked about my direct connects. Now let's talk about a direct connect gateway. This allows you to share your direct connect links in various regions with your on-prem sites. It's similar to a route reflector for all your north-south traffic, right? In hindsight, I probably would have drawn this a little bit differently. But I could have direct connects in 2 different regions. Let's say I've got direct connects in Oregon and I have direct connects in Virginia. And I could tie those all to a direct connect gateway so that I could kind of do route reflecting to get from Oregon over to Virginia across the AWS infrastructure. You still have the options for BGP and static routes. It doesn't change anything there. However, the Direct Connect gateway only handles a maximum of 20 prefixes. So you want to think about things like network summarization, right? You're definitely doing summarization with the Direct Connect gateway. You do want to keep things like latency for the region in mind, and you need to be aware that the Direct Connect gateway is predominantly a north-south solution, not an east-west solution. So it's not really a replacement for something like, say, SD-WAN. Now, I think we will get, these are a little bit out of, I deleted my transit gateway slide. Oops. That's something was missing. Let's talk a little bit about transit gateways and see what's happened here. Well, we're going to go off script because I was prepared for it anyway. Let's talk about transit gateways. These are going to be important because I have a whole section on these. Transit gateways, remember I said I'm not a big fan of VPC peering. That's because we have things like transit gateways. Transit gateways allow me to interconnect all my VPCs and transitively route between them, right? Remember, one of the limitations is I cannot transitively route within the VPC peering concept. However, I can transitively route through a transit gateway. That's the transit part of it. They're also way more scalable. You can do up to 5,000 routes, I believe, on a transit gateway. They can handle up to 50 gigabits per second. They support BGP. You can attach them directly to your VPCs at the subnet level. You can also terminate IPsec VPNs to them, right? So they're pretty flexible in terms of connectivity, right? So they can connect to your VPCs. They can connect to third-party routers or firewalls or VPN devices. They handle up to 50 gigabits of throughput, 50,000 routes. They support multiple routing tables. We're going to go through an example with, I think it's not with multiple routing tables, but they do support multiple routing tables. I would not say that they're the same thing. The multi-routing table concept is not the same as a VRF. It's VRF similar, right? Not as powerful as a VRF, also not as complex or difficult to work with as a VRF. If you've ever worked with VRFs, you know that they can be pretty complicated, but amazingly powerful for segregation. The transit gateway routing domains or routing tables are a little less granular, but a little simpler to work with, right? So transit gateways, by the way, we talked about on Direct Connects that there's something called a transit virtual interface or a transit VIF or a TVIF. The transit VIF is used to connect to a transit gateway. You connect your Direct Connect to a transit gateway via a Direct Connect gateway. Okay. Let's talk about endpoints. There's a whole bunch of different endpoints. I wanted to talk about a specific kind of endpoint, though. Endpoints are basically just you could think of it as a private VNIC or a VNIC in your VPC. So it's got to go into a single subnet. Pardon me. But you can have multiple endpoints that span multiple subnets, but each individual endpoint is in a single subnet, right? And one of the ones that's it's a little bit newer, not brand new, but a little bit newer, is called the private link endpoint. I'm running across these more and more. They're used pretty commonly, it seems, to encrypt data to go across a public AWS backbone privately, so that I don't need any public IPs, I don't need any IGWs, I don't need any NATs, none of that, right? So here's a common enough scenario, right? I've got my VPC over here. It has its CIDR block. I have a VPC over here. You can see it has a totally different CIDR block. And the order of operations is this side over here, the 172.16, is going to publish something called an endpoint service. So they create a service that would normally be a public service, but they don't want to make it public. They want to keep everything private, right? So let's say they have a load balancer that goes to this database over here. And they say, I want that load balancer to be published as an endpoint service privately, though. Over here, I can consume that service, and I consume it in the form of a private link endpoint. And some magic happens here. On my side, I don't even need to know about their 172.16 address space. So there's no limitation where they have to have unique IP space that needs to be unique for my IP space or vice versa. Because all of my traffic is going to hit this private link endpoint that I've configured that's in my address space that I'm already routing. And it basically gets kind of proxied over and encrypted and lands over here. And over here, they're doing the same thing. They don't know anything about our 10.1 space. They point all their traffic to their load balancer, which then reconverts it back over across and sends it to the 10. So this is all happening in the underlay. I can't really explain how because it's happening in the underlay. I've had multiple cases opened with AWS, and they've basically just said, yeah, you don't need to know, but we take care of everything. We shuttle it across for you. So the important thing with these endpoints and endpoint services is to be aware you're always pointing to your IP, not the IP on the far end, right? So I'm running across this more and more commonly. So it's probably something to be aware of. The last 2 times I ran across it, it was for SaaS deployments. So they had a SaaS deployment, and the customer was like, I would rather that there was no public access to that SaaS. I feel like the data was a lot more secure. And they say, yeah, no problem. I won't even attach an IGW into my VPC. We'll just do it with private link endpoints and we'll keep everything private, right? No public access whatsoever, only private access in. Any questions about that? Anyone else maybe who has experience with this? Okay. I think this is my last slide before we get into the tying it all together. Load balancers. We're only going to talk really about the network load balancer. There's 3 types of load balancers. They have application load balancers, network load balancers, and gateway load balancers. The gateway load balancer is really cool. It's kind of complicated, but it's really cool. It's great for working with things like security appliances or advanced segmentation, but it'd take a whole section just to probably discuss it. The network load balancer is similar to something like an F5 or an A10 or whatever load balancer you use today, right? It has target groups. Those target groups do keep alives. You could point to resources in your VPC. You could point to resources in a different VPC. You can even point to resources that are on-prem in your data center. You could point your network load balancer to a target group that just points to a VIP on an F5 load balancer or an A10 load balancer, or whatever load balancer you want, right? So they're very flexible. They're very scalable. I think they do up to 40 gigabits per second. They are configured at the VPC level, and you determine what subnets you want to attach them to. So in this case, I have 4 AZs or 4 subnets, and I've deployed my load balancer only across 2 of them, right? So they're deployed at the VPC level, but they attach at the subnet level. A little bit different than some of the other objects we've looked at. You typically do 1 target group per protocol. There could be a few advanced use cases where you might do multiple protocols per target group, but it's pretty rare. Usually it's just one target group per port and protocol. Any questions on load balancers? Pretty flexible. Boy, my slides are just struggling tonight. Oh, global load balancer in oh, that's true. You can do load balancing through Route 53. I left Route 53 off because DNS is my nemesis. I call you, Chad, if I need help with DNS. Maybe we should talk about doing an Infoblox session this year at some point. Yes, you're right. You can do global load balancing. There's a few different types of load balancing you can do in DNS through Route 53, geolocation. Oh, yeah. Hey, Chad, let's talk. I think we've got some interest in having Infoblox come in and do a presentation if you'd be interested sometime. Sounds like we need to get lunch soon, Mr. Willard. So let's talk about putting this all together. Let's take a look at multiple VPCs with a TGW tied in with a direct connect. Okay. So I've got 3 VPCs. We'll call them dev, test, and prod. They could be anything, doesn't matter, right? They're tied into, at the subnet level, they're tied into my TGW. My TGW does all my routing. And I also have 2 direct connect circuits. Those are tied to a direct connect gateway. And the way that those get up to my TGW is through a transit virtual interface, or TVIF. Now, this is greatly simplified. Like, I haven't pictured out things like my subnets. I haven't pictured out all my route tables. Um, you know, but I'm going to show you what it look like perhaps with route tables coming up in a minute. So this is kind of tying a lot of these concepts together, right? We would build up the VPCs first. In the VPCs, that we would next build out our subnets. We would then, after our subnets, we would perhaps build out our direct connect gateway. The direct connect gateway, I didn't go in depth on this, but the direct connect gateway is going to take a BGP ASN typically. We're going to create these things called attachments. That's how you see these get attached. Attachments run between the direct connect gateway and a subnet up here. And then there's routing tables on the TGW. So I would build all that out, and then up in my VPC, I would then create my route table, and I would explicitly associate it with my subnets, and I might put a default route that points to the TGW. And then on the TGW routing table, I might put a default route that points back to my direct connect gateway, right? Which gets me back to on-prem. So that's one option. It doesn't have to be the only option, but that's one way you could do this. And it works out pretty well. I've done this multiple times for multiple different customers. Let's look at something a little more complicated. Maybe I want to do something like multiple VPCs with a centralized internet egress, right? And I want my net gateways to be highly resilient, right? And I still want to keep in my direct connect, right? So I've got a lot of the bells and whistles here. And this time I drew out the route tables so you get a little bit better feel for how this looks like complexity wise. Up here in my VPCs, you can see the route tables are very simple. They just have a default route pointing into the TGW, right? Down here in my inspection VPC, where I might have, well, I didn't draw firewalls, but you could put a pair of like FTDs up here or virtual ASAs. Or if you're not a Cisco shop, you could also do FortiGates or PANs or just about anyone. But this is a Cisco user group, so I'll assume you have FTDs up there if you want inspection. Or maybe I only do outbound internet access and I don't feel it needs to be inspected because I'm not allowing anything to initiate from the internet into my VPCs. Because remember that the net gateways are one-way devices, right? So my routing table down here basically says, hey, default goes out the IGW. Anything at 10/8 goes back to the TGW, right? Let's look at the TGW route table. This one's a little more complicated. Default route goes to the attachment for my internet VPC, or what I call my inspection VPC attachment. And then I have a route to each of these VPCs up here through their attachments. And then in this case, I'm assuming that my on-prem is maybe 10.2.0.0/16. So I can put a route in my direct connect gateway that says, hey, if you're trying to get back to 10.2, you go down the direct connect gateway, and that goes to my on-prem environment, right? So again, you can start to see how we maybe put all of this together. Any questions? Okay. These are just some final tips and tricks. We're pretty much done at this point. So I did mention the free tier. And again, my email's in the chat. If you would like a copy of these slides, just email. I'll send them out to you. But this is the link to learning about how to set up your free tier. and also understanding what is actually free and what isn't. There are caveats. You can't just run your $100 million enterprise off of the AWS free tier. You could also just Google AWS free tier. You could Google Azure free tier or GCP free tier if you're more interested in one of those other clouds. Remember, not all, but most of the concepts we discussed tonight, they apply to any of the big infrastructure clouds, right? While I'm a little more AWS focused these days, um, I'm pretty cognizant that there are multiple clouds out there. So you do the one that works for you. There was a question that popped up. Hang on. How do you know when you need a virtual router appliance like a CSR 1000V instead of the native TGW or other? So that's a good question, Chad. Well, first of all, you never need a 1000V anymore because those have been replaced by the 8kV, which actually has much more scalability in terms of routing. But I would typically use, so you always want a TGW these days if you're doing this at any scale. Even for more medium-sized companies these days, I see them always going down the TGW route. It's just so much easier to keep it Amazon native. And the 5,000 route limit makes it much more reasonable than the old 100 route limit that we had in the old days with transit VPCs. However, if you're doing something like SD-WAN or that centralized internet concept, some of those, SD-WAN in particular, you may still want some third-party SD-WAN routers that are used to help connect your sites to your AWS infrastructure and your AWS infrastructure back to your sites or to your other clouds even. So if you're doing both AWS and Azure or Azure and GCP or something like that. The AWS, the SD-WAN, of course, can abstract all that and route between those clouds very seamlessly. So those are both use cases where you may still want a third-party router like an 8kV or something like that. Does that answer your question, Chad? Yep, perfect. Okay. You probably saw several recommendations tonight that I avoid or even delete default objects like the default VPC and instead create my own. I would recommend that you do the same and get into the practice of doing the same. Be aware that routing in AWS, if you're a router nerd like me, it's more like a routing service. There are a lot of scalability limits and lack of features. Even the TGW, which I've been kind of singing its praises, and I do like the TGW. And I don't speak for AWS, I don't work for AWS, but there are some rumors that there's some pretty good features coming soon to the TGW, maybe by reInvent this year, that's going to make it even more scalable in terms of routing capability. But let's be very clear, it does not have near the flexibility of, say, a Cisco IOS XE router. It doesn't even have 2% of the capability, not even 1% of the capability of like a, Cat 8K or something like that. So it is more like a routing service. And then if I go to older routing constructs, like the intrinsic router inside of VPC, I barely even call that thing a router. It's really, really limited, right? So just be aware of that. Hang on, that's another question coming. Try to do BGP Anycast on TGW, but it's not implemented. Oh, yeah. I haven't tried doing any Anycast. That's interesting. Yeah, let's talk about that, Chad. Sounds good. We're overdue to catch up. If you do a free tier account or you're just getting started in AWS, maybe you're not even doing free tier, maybe your company has said, look, we do need to get into AWS, and again, I say AWS, it could be Azure, it could be GCP. I'm fine with any of that. You may want to set up some kind of an alarming service. In AWS, we call it a CloudWatch alarm to alert on spending. Maybe your company says, yeah, I'll spend a little bit of money, but let's not go crazy. We just want to kick the tires a little bit. Maybe your alert is, hey, if I go above $100, I want someone to email me and warn me, right? On my free tier account, I'm cheap, so I set my alarm at $5. I've never triggered it. I have gotten charged on AWS. My biggest charge to date, I think, was $1.73. I'd spun up a TGW and forgot to shut it down, and I think I got charged $1.73 for keeping it up for an hour or something like that, or a day, or I can't remember. So you can set up alerts that kind of warn you on those things. We did not cover storage or S3 here, but I left this in here. We all see the headlines all the time, and I don't care, again, which cloud it is. I'm just going to pick on AWS and S3. Oh, all this data was leaked, right? Oh, 300,000 accounts leaked here or something like that. A lot of those leaks have to do with taking an S3 bucket or maybe a blob storage object over in Azure side or something like that, but a storage bucket and making it public. There's rarely a reason these days that you make one of those public. There could be reasons. There absolutely could be reasons. But in AWS, they've made it really difficult to make an S3 bucket public. They made it really difficult for a reason. So follow those reasons. Don't make an S3 bucket public unless you really have a good reason to make it public. We would cut down on some of those alarming headlines if we did this, right? I know I didn't talk about S3. We didn't talk about buckets, and that's all fine. But just be aware that if you have objects stored in a cloud, make sure that that storage mechanism is not publicly accessible unless it's literally meant to be publicly accessible. Just a good thought to keep in mind. And that's it, everyone. I'll go ahead and stop sharing. I think we covered a lot tonight. Had some really great questions. So I'm really glad to see that the questions coming in and some of the back and forth. I'm going to put my email in the chat again. If you would like a copy of the slides, you can just email me. I'll be happy to send you a copy of the slides. Or if you have questions, or like I said, if you have recommendations, thank you, Mary, for speaking up. I will work with Chad and we'll see if we can get an infoblock session. We're booked all the way through June, believe it or not. So maybe I can get Chad to cover me this summer or something like that. So I appreciate every one of you taking your time to come here tonight. I know it's not easy to spend a night. We do it once a month. We've been doing it now. Scug turns 24 this July, by the way. We'll turn 24 this year in July. So we've been doing this once a month for 24 years. And it's because people do still show up. So I do appreciate it. So thank you, everyone. Have a great day.
Need help? Call our cybersecurity team and book a consultation with us today.